get started with class. So we'll spend the first maybe 15 to 30 minutes reviewing what we did last week, and people can ask questions or any problems they had. And then today we will be covering abstract classes and static properties and methods. So let's review. So last week we covered inheritance, where you can have one class of object and have another class inherit from it, and everything that this class has, this class will also have, right? So in this case, we created we covered interfaces. We had a class called bin, where a trash bin could inherit or extend from bin, and then it would have all of the methods that bin had. We also covered interfaces. Interfaces are a way to guarantee that any classes that implement that interface have the same methods. Okay? So because Storable has the store method and bin implements Storable, bin must have a store method. And this allows you to treat different kinds of classes similarly. So if we have, where is it? So if we have a storable variable, we can put a refrigerator object into it, because a refrigerator implements storable, right? So because refrigerator implements storable, we can store refrigerator into a storable variable, and then we can use it normally. Is anyone confused? Do people remember this? Yes? I have one yes. It is okay to say no. So if I had, whatever, we'll just have to make it work. So if I have an interface called, let's say, Drivable, right? And it has some method called drive. Okay, that kind of works. And I can make a car that implements Drivable, right? Or I can have a truck that implements Drivable, right? And then if I have some variable that is of type Drivable, I can store either a car or a truck into it, because both of these implement the interface Drivable. So if I have, let's say I have an interface called, let's go with the car example again, right? So if we have some interface, hey, I can actually see it here, that works. If we have some interface called Drivable, right? And then, that doesn't show up in the recording, that's terrible. Actually, let's do something like this. Yeah, let's get super fancy. And then let's say we have a vehicle. No, let's say we have a wheeled vehicle. Yeah, that'll work. And then let's say we also have a plane, right? And let's say we have a car. We have a truck. Whoop. We have a truck. Whoop. I hit the getting too antsy on my keyboard shortcuts here. And then let's say we have an Airbus. I don't know. Actually, that's a terrible example because that's ambiguous as to what it actually is. This is so janky. You can tell I'm a total professional, right? let's call it a fighter jet. There we go. Oh, you guys get it. So okay. So if we have an interface called Drivable, and let's say it has a method called drive, right? That means that any class that, can I get a pointer here? That's a little better. Any class that implements this interface must define their own version of the drive method. It guarantees that a drive method will exist in any of these classes because they all inherit from Drivable. Okay? Does that make sense? Cool. So then, because we have that guarantee, this means that if we declare a variable that is of type Drivable, and when I say declare, I mean talking about like this area right here, we can store anything that inherits from it into that variable. Now you might be thinking, why is that useful? Well, let's say you're running a driving school, okay? And you need to make sure you're doing a driving school simulation. Let's say you're writing a program like that. And you have a collection of things that people can drive, okay? You don't care if it's a car, you don't care if it's a truck, you don't care if it's a motorcycle, you only care that it can be driven. So what you would do is you would have your collection, and you would say the things that I'm storing in the collection are drivables. And then you can store all of these things. Whoa, can you guys see that? Oh, wrong screen. Then you can store all of these things in there and treat them the same, without the complexity of having to have a collection for cars, a collection for trucks, a collection for fighter jets even, right? You can treat them all the same. So maybe it would help if I showed an example. So here, this is going back to the bin and trash bin and refrigerator example. Okay. We have, where is it? We can have an array list, right? A collection of items. And we can say we're going to store, it will, inside this array list, we will have items that are storable. Okay? And because refrigerators, bins, trash bins are all classes that implement storable, we can toss any of those into the array list. Okay? So you can see in this array list, we can add trash, which is a bin. We can add another bin. We can add a refrigerator, which is also storable, right? And we can add, doesn't matter, which we just said is a generic storable, right? Because they all eventually, correct. You can think, good word, you can think of interfaces as ways to guarantee behaviors. Because a method is similar to a behavior, right? So drivable means it can drive. Okay, so when you have an interface that says drivable or storable or whatever, it guarantees that whatever that object is can be driven or can store things. And then you're guaranteeing that the behavior will be the same among the different objects. So in this case, we have our array list, and we can say, hey, for each storable, run store. And because we know that everything in this array list is a storable object, we know it will have this store method, even though they're different kinds of objects. Oh, that was just a name I gave it? Yeah, so this could be monkey. It doesn't matter. It's just a name. So in this case, you could call it storing object, right? Will probably make more sense. Yeah, I was making a joke when when we actually did this. So yeah, this makes more sense, right? So yeah, in this case, we have an array list, a collection, and we're saying it can store any storable. Now this includes anything down the storable hierarchy. Okay, so if we have a storable, and then we have a bin, and then we have a trash bin, right, and they all inherit from each other, we can store any of those into the array. Same for refrigerator, which is implementing storable directly, right? We can treat all of these as if they were storable objects. That is the concept of polymorphism. Polymorphism is from Latin. Poly is many, morph is forms. So it means that an object can take on many forms based on the inheritance structure. ARR is this array list. Correct. Yeah, we do that here. Okay, we're just adding things to that array list. What's up? Yes, because if we look at trash bin inherits from bin, and bin implements storable. So you have trash bin to storable, and this works. You can go as many times as you need. Does that answer your question? Cool. And then, sorry, this is the collection that we want to take items out of and work with. And then this is the name of each object we work with. There's let me say that differently. So you can think of the array list like a box, right? And the loop is taking one thing out of the box at a time and working with that one thing, okay? So in this case, this is the box, and this is what we're going to call that one thing. We're just giving it a name. So this is storing object. Okay, we're done. This is storing object. Okay, this is storing object. Okay, and you have to declare a type. So in this case, the array list uses storables, so the type we're giving it is a storable. We cannot use int, correct? Because for storable, int is not within that hierarchy. Or I'm sorry, it would actually be the other way. Storable does not inherit from int. Does that make sense? So, yeah. So basically, polymorphism works up, but not down. By this I mean, when you have a superclass and a subclass, right? The base class and then the subclass is the one that is inheriting, right? You can treat the subclass like the superclass because the subclass is guaranteed to have all of the things that the superclass has. You can't treat the superclass like the subclass because there's no guarantee that this will have what this has. So there's no guarantee that... where's my mouse? So if I tried to say, hey, I have a collection of cars, and then I tried to store wheeled vehicles in it, that doesn't work. Because a car is, for example, guaranteed to have 4 wheels and a steering wheel and maybe 4 chairs or 2 or whatever, right? There's no guarantee that a wheel vehicle has those things. But there is a guarantee that if I say, hey, I want to use a wheeled vehicle, there's a guarantee that everything a wheeled vehicle has, a car also has. Does that make sense? Cool. So does that help this part out? Whoop. Does that help this make a little more sense? Damn. No, it's okay. Um, so also bear in mind if this seems really difficult, um, we're going really fast. Normally, what we're trying to do in about 7 or 8 weeks normally takes 18 weeks at minimum. So we're going really fast. So if things are hard, don't be like, oh my god, I'm stupid. If you're understanding this stuff at the pace we're teaching it, you're actually really smart. I learned this about 3 times as slow as how we're doing it here. So it's okay. We are intentionally going fast. Do you want to take a stab at this, Charlie? At explaining this why we're using storable for the for each. Oh, yeah. Loop construct. Hmm. Does that help? Cool. Teamwork. um, yeah. Back to the driving school example. It allows you to, if you know you have many different kinds of objects, right? So, woo! Good reaction. Anyone got a? Yeah. Okay. Um. So actually, let's take the example of this classroom, right? We are all humans, right? We all have similar behaviors. One of these behaviors is the ability to learn, for example. Now, we might have someone who is an accountant, or someone who is an office worker, or someone who is a programmer, right? They're all different kinds of people, but they share some behaviors, right? So even though we are different in many specific ways, um, because we share some behavior, with regards to that behavior, we can be treated the same. So if you have in your code many different kinds of objects, but you know that they all behave similarly, and they follow basically kind of that behavior interface, that allows you to treat them the same. what he said. Yeah. Feel like he's getting better at this than I am. Get back to... And then okay, we're tight on time. The last thing we covered were exceptions, where you can't always guarantee that the world will be perfect, right? For example, using the database example again, let's say you want to connect to some database. That database is outside of your application. You don't know what's going on with that database. Maybe it's down. Maybe you can't connect to it. Maybe it's full or something, right? So what you want to do is you want to try to connect to the database. And if something goes wrong, you want to react in an appropriate way. So in this case, and I just stubbed out some code. This is not valid, but it's just example. So I could do something like, actually, I remember. In this case, we tried to pull a value out of our array list that doesn't exist, right? Our array list is only 4 long. We tried to grab the 5th value. Yeah, go ahead. So in this case, we can say, hey, catch if a certain kind of error occurs, and if that error does occur, do this action. Okay? So in this case, we print that there was a mistake, we print a message, and then we might print the stack trace to error. We can actually run this at this point. So, maybe. Come on, you could do it. I believe. Oh, where is it? So, let's do this on out. There we go. So in this case, I don't know if you guys can read that. It's kind of small. Can I make this bigger? Not really. Yeah. Oh, that is terrible. Let's make that a little bit smaller. Ah, how's that? There we go, kind of, more or less. Okay. Good enough. So, in this case, this is the error that occurred, right? But our code kept running, right? Because we saw that there was an error, we handled it appropriately, and then we can move on. So that's what try catch enables you to do. You can try a series of actions that might cause an error. You can catch certain kinds of errors. You can react to them, and then you can move on. So in this case, we actually said, hey, regardless of whether or not an error occurs, go ahead and print this, and you can see that that showed up here. This prints no matter what, right? So even though something went wrong, the program was still able to continue, okay? So again, that's try the behaviors that could break, catch the possible errors, and then carry out your reactions. So let's move on to new stuff. All right, everyone, so if you can, go ahead and open up whatever it is you prefer to use for your programming. Here we go, whether it's Eclipse or IntelliJ. Today we're going to be covering abstraction and statics, okay? So let's go ahead and create a new project. Yeah, we should be good. And again, select Java. You don't need to select any of these. Make sure you have some sort of SDK up here. Next, there we go. And then next. And then let's call it abstract static. Did I? Yeah, I moved it. Okay, cool. Alright, and you should have a new project like this. And then let's go ahead and create a new Java class, and let's just call it main for now. We're not going to bother with packages because we're not doing anything super crazy. And then as usual, let's go ahead and create our main method. And then that's where we're going to do most of our work, but now we need to create a class that we'll use as an abstract. So let's go ahead and create a Java class, and let's call it helper. Okay? Before we do abstract, let's actually do static. So sometimes there will be cases where you want a value to exist, you want some number or some text or something to exist, but you don't need it on every single instance of an object, right? So let's say that, let's say we had a model of a car, for example, right? We don't necessarily need, or let's say we had a model of car like, I don't know, let's be fancy and say we had a Mercedes-Benz, let's call it Model X. I don't know anything about cars. And let's say the Model X's maximum speed was 200 kilometers per hour. I don't even know if that's fast. You don't want every single Mercedes-Benz instance to have that value. That's unnecessary. Sometimes you just need to know that for any Mercedes-Benz, there is this value, maximum speed, and it will be true for all of them, right? In that case, it might be useful to use something called a static. So what we can do is we can say, let's continue with the car example. We can do public static integer max speed. Let's just say that's 200. All right. And then, whoa. Okay. So we have that, right? Now, we have no objects here, right? We only have main. We have not created any new object instances. But we can do something like, oh, come on. Really? Oh, it doesn't like that. Okay, hold up. This works. Should have done this at the beginning, my mistake. Make sure to edit your configurations. Hit the plus sign. Application. We've done this, what, 3 times now? So you guys should call it main, and then select your main class. Okay. Okay, and now we can run it. You can see that this prints out just fine. You'll also notice this is the name of the class, okay? We never created a helper object. You don't need to. That is what static allows us to do. It allows us to define a value on a class that we can access without needing an object instance, all the vocabulary, from the class. Okay? Does that make sense? The reason you would want this, again, using the kind of the car example, you don't like max speed is not going to change from model of car to model of car, right? But you still need that information. So that makes it a good candidate to use as a static. And also to make sure that that value doesn't change, there's another modifier we can use, right? So static is one modifier. Another one we can use is final. And final only allows us to set the value for this once. If we try to set it again, it will fail. For example, if we try to do this, you'll see that we get red squiggly lines, cannot assign a value to final variable max speed. Okay? Does everyone see that? And if we try to run it, it'll say the same thing. Cannot assign a value to final variable max speed. However, if we didn't have this, we could change it. You'll see that I removed final, and you can see now that it allows us to do this. Or, whoops, let's put this afterwards. How about that? You can see that this changed. But now, anytime you try to access this value, it will use the new one. Okay? The new value. Again, pretty basic stuff. Not only can we have static properties, we can also have static methods. So we can do something like this. We have an add function. Okay. It returns an integer, and it takes in 2 integers as inputs, and returns their sum. Right? Pretty basic things. And then from here, we can just like how we access this on the class rather than on an instance, we can do the same with that function. So you can see the sum prints out as 5. Yeah, because we're calling it as a static method, right? So, really? Come on. Oh, that's right, it does it on there, but not on here. So you can see, and then it turns italic, right? Now that's just from IntelliJ. If you were to do that in some other sort of text editor, it might not do that. Okay. And that's pretty much statics in a nutshell. Not rocket science. The complexity comes from when it is a good idea to use static and when it is a bad idea to use static. But those sorts of things we'll cover when we start doing more workshop style things next week. Okay? Yeah. Sorry? So it is a way to access properties or methods on the class instead of on an instance of an object. So it might be difficult to understand if you don't have a grasp on classes and objects yet. But in a normal, so let's say I had something like this, right? Let's say I had a current speed, it's not static, right? And I try to that does not work. Because current speed is defined not statically. So that means it must exist on an object. Now, if I were to do something like this, now that I have, this creates a helper object, and we store it into this variable. Now that we have that object, we can access its current speed. Okay? So static allows us to access things without an object instance. Okay, what's up? So it is a way to guarantee behavior, or there's several. So one way is kind of as a reference, right? So the maximum speed for a car, let's say, that will not change from object to object. So storing that data in each object is kind of wasteful, right? If we store it on the class, it's stored in one place, and we can access it from anywhere, depending on access modifiers. It can also be used to track state. So if you don't make it final and you were to change that value, it would change everywhere. Okay. Does that kind of answer your question? A little bit, yeah. Depending on how many objects, either a little bit or, yeah. Yeah. Another example that might help is, let's say you are making some sort of graphics software, right? And let's say you had some sort of color object, right? You might have, you might make instances of colors, right? So you might have a red color, you might have a blue color, right? And they might have methods like change hue, change saturation, all those sorts of things. But then you might want some reference values, like pure red. So you might have color, like, you might have a static variable on the color class called pure red. And that might be whatever the red data is, FF0000, right? That would be shared as reference material among all of the objects, right? And it says something to anyone else who may be working with your code. Use this as reference. Does that make sense? Okay, cool. Yes. So that's what we did here. Right. So in the case, if we use the color example again, we could do, oh, there's so many ways. We could do using change hue as an example, right? Or here we go. Converting from, do you know anything about graphics or not really? Yeah, right. So you know RGB versus hue, saturation, luminosity, right? That conversion, like convert RGB to HSL, I think, like that will always be the same. It doesn't matter because you can just feed it those values and the logic will always be the same among the values, right? So that might actually not be a good example, but you get, yeah. It's for operations that always behave the same and they don't need any complex data. Now, for that specific example is not great because you could have, actually no, here we go. So let's say we had that conversion method, right? You could have two versions. You could have one that takes in an original color and a target color, and that would be static because it doesn't require any additional information to do its work, right? Similar to this add. Everything that you need is on the inputs. It doesn't need a whole object of information to pull from. The second way that you could do the color conversion thing is if you had a color instance, right, with its own values, you could just say, this is the target value. This is what I want it to become. And then that version of it, you can use the data already inside the object for the source. So source to destination. This might be very confusing. Okay, cool. Yeah. So, for example, one common one is like math dot absolute value, right? So, whoop. So math is a class, and absolute value is a static method, right? It just takes one input, and it will. That's all it needs to do its job, right? So that is actually a great example of a static method. It will always behave the same without any sort of object instance. It just relies on the inputs. Okay. So let's do abstract now. Let's go ahead and finding that I should employ more metaphors. So now I need to think of a good metaphor for abstract. Let's say, let's, yeah, right? Which makes it that much harder. Let's call it an abstract writing tool. There we go. So let's create a new class. Let's call it an abstract writing tool. And let's go ahead and I'll explain everything in just a second. Let's call it public abstract class, abstract writing tool. Excuse me. We're doing good on time. Okay. So what is abstract? Abstract means that you cannot create an object instance. Okay. So with this, right, this abstract writing tool, okay, if we were to, and don't type this because it's not going to work, if we were to create an abstract writing tool object, that name might be too long. It's going to complain. Abstract writing tool is abstract, cannot be instantiated. Okay? So why would you want this? In an object-oriented world, why would you want a class that you can't turn into an object? Well, this is why this is taught with statics, right? If we look at math as an example, right? Math is kind of an abstract concept, right? You can do operations with math, but you can't, like, again, it's an abstract concept, so you can't create a math object. Like, if I were to ask Kelly, like, give me an abstract object, or I'm sorry, give me a math object, you'd be like, how? What is that? That doesn't make sense, right? So in this case, math, kind of like you mentioned before, is being used as a library, where it has a series of static methods, right, that operate. They don't need any context. They don't need the context that an object provides, right? So, so in this case, there's no need to ever create math because it's just a series of operations that we can use, right? Math doesn't store any data, right? It doesn't have any relationships to other objects. It just has operations, right? So math is actually a great example of an abstract class. There's no need to create an instance of it, and it doesn't make sense to. So that's one of the main uses of an abstract class. So that add method that we made, for example, that, or let's do the color change thing, right? Except I don't know the math behind that, so let's do something else. Public static. Let's just go with some basic. Let's just do subtract. I don't care at this point. So int A, int B. There we go. Right. That would be, again, kind of like math. We're just a library of methods, right? Woo, if I could type, would be great. Right, so that's one example of why you would want an abstract, kind of just as a repository of static properties and methods, basically kind of reference things. But we could also use it to get into a little bit more detail about how certain objects should be without actually allowing you to create that object. So a writing tool itself is not abstract, right? But maybe there's some behaviors that we want to, behaviors and properties that we want to enforce in many writing tools. So let's say we had, so let's say we had, writing tools include things like what? Pens, pencils, paintbrushes, calligraphy pens, right? These are all different kinds of writing tools. And some things that they might all share might be materials that they use, or the thickness that they write in. Actually, hold up. Let's use proper types, huh? And normally wouldn't make these public, but I'm just trying to get things done quickly. And then we might have something like this, right? So a writing tool has some material, it has some thickness, and it can write because it's a writing tool, right? But because there are so many different ways, there are so many different kinds of writing tools, we may want to guarantee that certain properties exist and have kind of a basic behavior without allowing this kind of baseline writing tool to be created. That is one case where abstracts come in. Not very often, but sometimes this is a good case. So then we can create another class. Let's call it a pen. And we can say that it extends abstract writing tool. Typing is hard. And then we're guaranteed that a pen has a material and a thickness, right? Because it inherits from writing tool. But it prevents us from creating a new writing tool. So now, with no extra work, again, thanks to polymorphism, we can say that, hey, our variable is an abstract writing tool, but we're actually going to give it a pen, right? Again, this is kind of similar to what we did last week. And then with that pen, we can write something. Now, the nice part about this, this is somewhat similar to interfaces. Whereas interfaces guarantee behaviors, extending from an abstract class also guarantees properties. So you might be thinking, well, why would I use an interface when I could just use an abstract class, right? They both, through polymorphism, guarantee certain things. Why do we even need interfaces? Well, the reason being, the main reason is that a class can implement many interfaces, right? So we could create another interface like writable or erasable or, right, all these different behaviors. And our pen can implement all of those different behaviors, right? But it can only inherit from one class. So let's pull, where did paint go? Paint, where are you? Let's do this again. Right, so, oh, wonderful, it popped right up on the recording. So, yeah, let's do it this way. Actually, let's do something like this. Here we go. Okay, cool. Interfaces will be prefaced with the letter I. let's do holdable. I'm trying to think of a way to illustrate when you wouldn't need this, or wouldn't want this. I might need some help here. So in this case, these are interfaces, right? And they guarantee certain behaviors, right? Now, here we go. No, too long. Good enough. So, and let's do this, right? Oh, this might be a little bit messy, but I think you guys will get the general idea. All right. So, and maybe I'm trying to do too much, but let's try it. So, in this case, you can implement many different interfaces, okay? Because it makes sense logically that you can have many behaviors, right? So, in this case, both of these classes can inherit or can implement multiple interfaces, but you can only extend from one class. For example, if we tried to make this hand printer, you can't do this. You cannot extend from multiple classes. Okay, so that's why you would want to do something more like interfaces with abstract classes. I was going somewhere with this and I completely lost track. Because there's a problem called the diamond problem. Let me open up another MS Paint instance. Let's get recording of it. So if I had the reason being let's say no, let's do and then that seems too small. We'll use the indentation to so let's go with writing material. Although I don't remember, you see some of the more theoretical stuff? Or no. Typing is hard. Right, so if you had... And this is not the greatest example. But the general idea should still get across. So this is called the diamond problem in computer science, and it has to do with inheritance. Right? So... let's say I have... why can't I... there we go. Let's say I have some generic kind of writing tool, okay? From that writing tool, let's say I create a new object called a pen that inherits from writing tool, and a new object from a pen called a pencil that also inherits from writing tool, right? Now, these are all classes, none of these are interfaces, okay? If I try to create, let's say, a combination pen and pencil, and it tries to inherit from both, there's going to be collisions, right? In this case, each of them has defined their own unique writing material, right? So which one does this one use? Right? Each of these must have a writing material because they inherit from writing tool, right? But in the case where they define that writing material differently, this is a problem because there's no way to determine what this should be. So this is why you can only extend from one class. Now, the reason that you can implement many interfaces is because interfaces guarantee only that there is a method with a specific method signature, a method with a certain name, outputs, and inputs. It makes no guarantee about the behavior. So that is why a class can implement many interfaces, but can only inherit from one class. Okay, because the method signatures, they can differ just fine. There's no chance for collision. With things like full method definitions, like what the steps are for each method, and for things like properties, there's a possibility of collisions. So Java solves that by only allowing you to inherit from one class at a time. Does that make sense? I don't find myself using abstract classes very often, but when I do need them, they're really nice to have. Let's say that we have... I'm going to make some fake functions here just for time purposes. We've guaranteed that any abstract writing tool will have a material and a thickness, right? So we could do something like write onto paper and it would take in the material and the thickness, right? But then, so that's kind of in our abstract class, right? This is a fake method, this won't actually work. But in our pen, we might do some sort of override for write. Whoa, typing is hard. And in that, we might do... Now, I wouldn't do it in this exact way. This is actually poor design. I'm just trying to demonstrate a point. So in this case, this might actually be a good chance to do something like... oh, hey, that's a good idea. Let's do that. Except I have the wrong thing up. Okay, here we go. So in this case, and again, this is not exactly how you would want to write this. I'm just demonstrating a point. The abstract class has some kind of base behavior, right? There's things that are going to be common to all classes that inherit from it, right? They're all going to write in a certain way. But, and we don't want to have to write this in our pens, in our pencils, and we don't want to do that every single time, right? So by using an abstract class to at least carry out a few simple steps, like guaranteeing that there is a thickness and a material, That just saves us writing some code, right? And with polymorphism, we can also guarantee that, again, if we have a variable, we can say, hey, it stores an abstract writing tool, but we know it has a thickness and a material, right? Similar to the reason you would use interfaces. So the reason you would want to use an abstract class over an interface, for that use, there's other reasons you would want to use abstract classes too, but for that specific use, is when you have some base, some actual behaviors, like the steps within functions or properties that you want to guarantee among all the children. But you don't want to be able to create this. Okay, we're saying, hey, we want all of the things that come from this to behave in this way, right? But we don't want you to actually create this. We want to only allow you to extend from it. Does that answer your question? The concept you're trying to describe is okay, now maybe not. You cannot use it directly, but you can inherit from it and then use it. Right? So I can't, if we go to, am I good? I'm good. So if we were to go to, let's just do, I want a fake function. Actually, we'll just let Java complain at us. So in this case, for my pen, right, I'm changing the material. Again, this is a terrible way to do this. Here's a better way. Here's a better way. Let me demonstrate a few points here. As we demonstrated before. Whoa, no, go away. No. Oh, jeez. Whoa, holy crap, I'm sorry guys, my keyboard skills are not there today. There we go, okay. This doesn't work, right? We can't create an instance of an abstract class, right? But because the abstract writing tool has those properties guaranteed, I can still do, whoa, hello caps lock. Oh, damn it. Okay, I can still access these, right? Now, this isn't, my object is, we're treating it like an abstract writing tool, right? Because that's the type we've defined for the variable, but it's actually a pen. So it has whatever material is defined by the pen. Correct. But we're guaranteeing that, because we're saying it's an abstract writing tool, we're guaranteeing that the object has those properties, right? If I had created a pencil class, right? Now it's going to complain at me because I haven't actually made it yet. You could still access that material. Actually, that's a really cool point right there. Because even though I haven't actually made a pencil class, because abstract writing tool guarantees that the thickness and material will be present, it still knows that they're there. So does that? Cool. We can demonstrate that too. So let's say that here we go. So let's say we create a writable interface to stick with the example that we have. And let's make it an interface, not a class. And we say public void write. Okay, whoops. Whoops, 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 whoops. Okay. So we have this interface writable. Okay. And it says that anything that implements this interface must have a write method. Okay. Now, if I create, I'm going to kind of break the example we made earlier with this new example, but we'll fix it up at the end. If I try to implement that writable, it's going to complain at me. Wait, what? Ha, typing is hard. There we go. It said it must either be abstract or it must implement the write method, right? So it's forcing me to adhere to the constraints that the iWritable interface has. Okay, so that's kind of what that's what Charlie's describing. Right? So if you were making, let's say you had some sort of writing tool factory, right? And you wanted other people to create their own writing tools. But you say, hey, you must implement iWritable. That will force them to create this write method on whatever tool it is they make. So in next week, we're going to be, basically, I'll have a game created. I've actually already done it from the Python group. I'm going to port it over to Java. And next week will be more of a workshop style, where we'll have some things like this. I don't think I'll have an abstract class, but I may have one or two static things, depending, to kind of demonstrate when it might be a good idea to use it, along with kind of going over all the other things we've done, like polymorphism, inheritance, all those sorts of things. So that'll, basically this is, for maybe the next 3 or 4 weeks, the last full-on lecture style we'll do, because it's been a lot of pumping information into your heads and not giving you much of a chance to use things. So starting next week, we're going to be more using everything. So we're going to be building small applications to really help you really understand all this information that we've been giving. So you'll have the chance to see static in action. You'll have the chance to see interfaces in action, inheritance, all these sorts of things. So yeah, again, next week we'll be doing a game. After that, haven't figured that out yet, but we'll doing more hands-on stuff. Next week we'll also be at Google Campus, or Campus Seoul, which is sponsored by Google. Much larger classroom, nicer facilities. More experienced folks are welcome to come as well, especially since it'll be more workshop-y than lecture. People will be doing a lot more work themselves and may need more guidance. So if it's only me, I'll be very busy. So yeah. We're also, I think I want to say 2 or 3 weeks, we're going to do a social event. Because we've kind of split off into these 3 groups. And like some people participate in multiple groups. But it'd be nice to get everyone together and get people to know each other. And part of this is to build community. And it also helps you get to know people that you can be like, hey, can I ask you for help? Or hey, maybe we should do like study session together outside of the normal class. These sorts of things. So it'll be a nice way for people to connect. We're thinking bowling, because it's an activity which is an icebreaker, but it's still easy to talk with people. Oh, if you're new, we have a Slack channel. You can find it. Oh, where's my mouse? At learntocodela.herokuapp.com. Because again, we're a branch of the LA group, and we didn't want to have to create our own Slack channel and all that, or our own Slack team. So if you go to this website, internet, come on. Really? That's weird. I guess the internet's just being slow. If you go to this website, it has just a simple little form. And you put in your email, you'll get an invite, and then you can sign up. Oh God, there we go. And there's a channel in there for the general Korea group, And then there's like a Python KR, a Java KR, a JavaScript KR. I strongly recommend that when you join, you mute the general channel because a lot of people are in LA, so you'll be getting notifications overnight. And it's a good place to kind of ask questions or, well, really to ask questions, or if you find something cool about code or technology that you want to share with people, I'm sure they would appreciate it. That's about it.